Okay, so our next speaker, Dr. David Parker. Dave has more than 30 years experience in the space sector, working across industry and government organizations. He is now the head of human and robotic exploration at ESA, which has got to be the coolest job on the planet. So without further ado, I introduce Dave Parker, who is going to talk about the future of exploration in Europe. Dave.
Thank you very much. It sounds working now.
I believe it is.
Very good. Thank you very much. I was trying to remember whether I was at the first Appleton conference, but I realised I reached that stage in life where I actually can't remember where I've been, what I was doing last week, but I definitely know I was at the ESA Ministerial last week. And so there's probably a clicker here, yeah. I'm going to very briefly summarise what happened at the ESA Ministerial, and it allows me to say, first of all, congratulations to Rebecca, Paul, the entire UK delegation to have achieved what you achieved. The message that the UK is and wants and will continue to be a strong partner in ESA was well received. And so I'm going to start straight off with some numbers. The last ministerial in 2019, which was the last time, I guess, I was here physically for a conference, the last Appleton conference, just after the ministerial in 2019. The agency secured 14.5 billion euros of investment, this time of 16.9, which in a context of a global economic crisis, inflation, a war on the mainland of Europe is a remarkable achievement. And it is a team sport. It's all the delegations, it's all the member states coming together. It's the ESA partnership, inside and outside, really working together very well. And the headline figures there show the kind of distribution of investment. But it's maybe actually this chart that is also instructive because it shows you a comparison between what happened in 2019 and this time in Paris. To see I'll talk about my program in detail in a moment, but the key goal for us was to bring exploration up to broadly the same level of investment as space transportation and Earth observation. But the underlying policy and political message of this ministerial was very clear. It was about European strategic autonomy. It's the recognition at very high political levels across Europe that space is fundamental for security, for defense, for autonomy, for the strength of an economic and industrial base in Europe. And the experiences of this year flowing from the Russian invasion of Ukraine have hammered home this message that autonomy and independence is something very important to the leaders across Europe, because losing our ability to launch Galileo satellites, Copernicus satellites, the ExoMars rover, which hit my program very, very strongly, was a very, very hard message to learn. And the reaction to that is exactly to increase and to reflect on the need for autonomy. And to answer a question from the back, from one of the earlier questions, there's a very specific program line within the technology element related to securing European autonomy in components. Doesn't sound very glamorous, but it's fundamental. If you can't secure in Europe components that you need for space, you don't have a space program. Overall, you can see where the growth areas were. I particularly highlight the growth in the space safety program, which includes orbital debris, managing orbital debris, dealing with that. The issue of space weather, and the UK is taking a very, very strong lead in space weather through the Vigil mission. You can see, for my own part, how we managed to grow the exploration program. We created in 2016 with 1.4 billion of investment. The last ministerial was 1.9 billion. We've now reached 2.7 billion, which I'm very proud of, very pleased of, but I always have to remind people, NASA's exploration program is spending $200 million a week. And that's how the scale of investment that we're working with. And you can see the distribution of investments among the member states, with the UK sort of solidifying its position as around 11% of investment across ESA. Italy came in particularly strong. Italy's investments in optional programs is now roughly on par with Germany and France. Their investment in mandatory programs being much smaller because of the... So, having said all of that, there was a fantastically successful ministerial for the agency as a whole. And now we're able to go into the next stage, particularly of the program I'm responsible for in human robotic exploration. And I always say Exploration is the combination of curiosity and opportunity, the curiosity to venture out into the unknown, the opportunity to bring back to planet Earth experiences, capabilities, innovation, and economic benefits that you only get by going out there with our human and robotic explorers. And so exploration is this combination of new knowledge, scientific discovery, innovation, global partnerships, and answering challenges on a global scale, and of course, inspiring the next generation. And there's nothing more powerful than that than our astronauts. The whole structure of the program, looking out, we've spent an exercise over the past 18 months to set out a long-term strategy for exploration. We have been living and working in low Earth orbit now for more than 20 years. We will continue to do that. Europe has to work out what it's going to do when the International Space Station comes to an end. We have an ambition to get a European explorer onto the surface of the moon by the end of this decade, working through the Artemis program, and to share in the NASA vision of eventually sending human explorers to Mars. A key emerging element is this recognition that most of the cost of exploration is transportation. If you don't have independent transportation capabilities, you don't explore. And the question is therefore being raised at the very highest political levels, let's say in the Élysée Palace, about the need for European autonomy in both cargo and crew transportation to low Earth orbit and beyond. So the long-term vision is set out. The short-term practical activities that are associated with our program are three destinations of low Earth orbit, Moon, and Mars. And for this ministerial, the political decisions were essentially threefold. To make the political decision to extend Europe's participation in the International Space Station out to 2030. NASA, the US government took that decision 1 year ago. Japan took that decision 3 weeks ago. And now Europe has made the decision, and we wait for the other partners to make it in due course. And associated with that was therefore the logic to have a selection campaign for a new generation of European explorers. I talked about transportation and autonomy. We are embedded in the Artemis program by building European service modules that are powering Orion capsules to the moon and bringing astronauts to the moon and back again. We are building the infrastructure around the moon with the Lunar Gateway in partnership with NASA. But with Argonaut, the series of large logistic landers with the first launch in 2030, we will be able to take cargo, science, infrastructure to the surface of the moon in support of human exploration, but also to act as a focus to bring other international partners to work with us in lunar exploration. So Argonaut was the second key decision, and the third was the rescue exercise to find a way to take our scientific jewel, our mission to the ancient solar system, the Rosalind Franklin rover to Mars. And again, the UK played, and Paul and his team played a particularly strong role in securing that. Now, what we do, I talked about new knowledge and science. It's very important to understand that embedded within our program is a lot of scientific activity. Our program provides a range of scientific facilities, not only the International Space Station. If you're a medic and you want a job working in the Antarctic for the next winter over season, we're recruiting right now for the next scientists who will work in our space station on planet Earth, the Concordia station in the high Antarctic. It's an example of this range of scientific facilities the program enables. The International Space Station is the largest single platform for science that we enable. It does Earth science, for example, the Atmosphere Space Interaction Monitor, looking at mysterious phenomena above thunderstorms, fundamental science regarding plasmas, fluid physics, and also human physiology research. So the space station is a place where dozens of astronauts have done hundreds of experiments on behalf of thousands of scientists across Europe. The people who do that are our astronaut corps, the existing astronaut corps you know very, very well. And we've had an extraordinary series of missions, back-to-back missions because of the investment of the last ministerial. Thomas Pesquet became commander of the International Space Station on his second mission. Today, he's with President Macron, visiting NASA HQ. And participating at the very highest level in space diplomacy. Matthias Maurer undertook his first mission. Very excitingly, Samantha undertook her second mission and became commander of the space station. Next year, Andy Mogensen, the Dane, will fly to the space station on his Hugin mission. But this year was very much the year of Matthias and Samantha. Samantha's mission means that she became also commander of the space station and now has the record. Only one other astronaut or cosmonaut has more hours, female astronaut or cosmonaut has more hours in space, the amazing Peggy Whitson. But Samantha is really a hero, and we've had the chance to meet our other astronaut, Matthias Maurer, in orbit earlier this year, and also operated the European robotic arm for the first time, which was installed aboard the space station last year. But our astronaut selection this year was big news, of course, and it was, if you like, one of my own pet projects was also to associate it with the so-called para-astronaut project. We've invented this word, para-astronauts, meaning the process in parallel to the regular astronaut selection. Here are the 17 people that were selected, including John McFall, the first para-astronaut. Where are we going to fly our astronauts to? The International Space Station, but also the Lunar Gateway that we're building around the moon. The modules are under construction. 2 out of the 3 modules are responsibility of ESA, and they will be launched. And I don't know how I make the movies work. Yes, it is a touch screen. An image of Artemis 1 stacked and prepared to launch that I took earlier this year in the vertical assembly building in the Cape, just to give you an impression of the size of it. But the European service module aboard, that is later this day, having taken Orion to the moon, will carry out a burn to start the return from the moon to Earth. And you mentioned 3 UK astronauts were selected in this process. You forget there is a British sheep aboard the International Space Station. So if you want a Bartemis mission patch, there are plenty of them at the front here. But we will, I show this movie very briefly to make the point that Artemis 5 will take the European refueling module to the Lunar Gateway, and UK companies are involved in assembling or designing and hopefully assembling contributions to Artemis 5, the European refueling module, the first time in-orbit refueling, let alone in-orbit refueling in deep space of both cryogenics, of storable propellants, and gas for electric propulsion. Now, for Moon, we have a long-term goal of sustained science and technology on the surface of the Moon. To do that, there are a lot of steps necessary, and I highlight communications and navigation, transportation, space resources work, all things that we are doing now. The first payload to go to the surface of the Moon, built by ESA, involved the Rutherford Appleton lab. It will go on the Astrobotics Peregrine lander next year, the exosphere mass spectrometer, and there are a series of further scientific instruments that are being built to kick off our campaign of science. But the big flagship project now are the European Large Logistic Landers, and thanks to the decisions made at the ministerial, we'll be able to issue the invitation to tender in the next months and select a prime contractor to build the first of these, and what we intend to be a series of missions throughout the next decade. We're also putting in place the facilities back here on Earth, a major new lunar simulation facility developed in partnership with DLR that will be located next to the European Astronaut Centre in Cologne. But not forgetting Mars, and coming to the end of my journey on our mission, on our program, the ExoMars Trace Gas Orbiter continues to do great science, and as a result of the ministerial, we'll be able to continue mission operations for the next years. But most importantly, the ministers have given us the confidence to go forward to find a way to get Rosalind Franklin to the surface of Mars. It has been an enormous challenge, and the answer to the question is a resounding yes. So thank you to the ministers, thank you to UK Space Agency and the department for giving us this vote of confidence. We are already hard at work designing the vehicle that will take Rosalind Franklin to Mars, and we will be in discussions with NASA in the next days about the launch that we will need and other technologies to support that mission. But not to forget Mars Sample Return, our biggest program of cooperation with NASA, literally with the size of the spacecraft. The Earth Return Orbiter that illustrated here just shows how enormous it is in comparison to any other deep space spacecraft to go to Mars and come back again. And if I may allow myself the video to just show you the amazing challenge of the Mars sample return mission. We have acquired the first 10 samples now with the Perseverance rover, and later this decade, a new lander will arrive in order to bring those samples back. So here's the samples being transferred by the European Robotic Arm, the sample transfer arm, into the Mars Ascent vehicle. The first time a vehicle will be launched off the surface of another planet. The capsule is released, the sample container biologically isolated from planet Mars, thrown overboard into deep space for the European orbiter to capture it. A rendezvous hundreds of millions of kilometers away from planet Earth, robotically undertaken. And the capsule then isolated and returned to planet Earth on its long journey back and released. To land in the deserts of the United States. Truly the most ambitious mission of robotic exploration that humanity has ever attempted. Thank you very much.
Wow, Dave, that's truly inspirational, and it's amazing for me because as a child I always wanted to walk on the surface of the moon, and it's the reason why I'm in space. So to hear that the plans are becoming reality is absolutely phenomenal. And I would encourage you to pick up a patch at the front here. This is not for my children. This is for me, because who doesn't like a mission patch? Yeah. So let's be honest with ourselves. Yeah. Dave, thank you for an amazing talk. I'm sure there are lots of questions. I'll start with the floor this time.
Hello, I'm actually an artist, so therefore I'm going to ask a question about that. You've just shown us absolutely extraordinary and amazing things, a lot of which I didn't even know about. I just wonder where you see art and culture fitting in to this, because you can't leave us out.
Oh, I wouldn't dream of it. If you would like to come and visit us at the European Space Agency Technology Centre, you will find that we have a lot of graphics around our main space, Erasmus Space Centre, where we do the exploration activities. We ran a competition with graffiti artists about a year ago. We brought them to the centre, talked to them about space, and then they went away to produce a series of massive pieces of graffiti art about the theme of space and space exploration, and we brought them on site. You will also find painted portraits of all of our current group of astronauts, and that artist has now got a challenge with 17 more to paint. So I absolutely, we are absolutely at that interface of human culture between what the brain can imagine and what the heart can make happen.
Fabulous question, thank you.
Thank you. Thank you, Dave. That was a great talk and very inspiring stuff. I guess I was going to ask you, perhaps this isn't wholly fair, but I was going to ask you a question about...
Were you ever fair?
Probably not, probably not. I should say from the Royal Astronomical Society, we've been raising this issue, but the one area of the ESA budget notably didn't get a significant uplift was space science. Yep. You know, and I think there is a lot to be said. Absolutely, you know, space is a team sport, and we're, I think, an instrumental part of that. You know, we're responsible for inspiring people like Paul to pursue his career in this area in the first place. So looking forward to the next ministerials I feel we've now got to do, can we be more optimistic about that, assuming slightly more clement circumstances? Because, you know, I think it's been a huge part of the success of this space science program. Has been extraordinary, and it would be a shame if that was allowed to wither.
As a former UK delegate to the Science Policy Committee of the Science Programme, the science programme is very close to my heart. And it is a frustration that somehow the consequence of the way the science program is funded, i.e. it's mandatory and it's a cash-based solution, has given it the challenge to make the case for why it should have a growth in the current context. So it is essentially going to be flat or slightly declining for the next few years when you take into account inflation. I believe there's clearly going to be a new director in post very shortly, and I think the team will regather their thoughts and make the case even more strongly as to why science is fundamental backbone of what ESA does. It goes right back to the start with ESRO, 1962. The science program, like exploration, is about technology innovation as much as what it delivers in the scientific value. And look at James Webb, look at Gaia, look at all of these missions. What ESA does on its science budget is extraordinary.
Okay, thank you. I'm sorry, we're going to have to move on. Dave, you're going to be around for a while, aren't you? So plenty of time to chat to Dave over the breaks. Thank you very much, Dave.